So one of the first points of integration that has been out there is we've been seeing this, a lot of the GIS to CAD integration has been, one of the biggest problems is there's a break between what design is doing and what GIS is doing. Typically, most GIS systems, and this includes the Autodesk template-based model as well as the most Esri models, they have a physical network of the poles, and then they have a electrical network of the connectivity. However, the physical network and the electrical network aren't talking to each other. So this, in the design, you design on top of the poles. So it's getting the data to move from the GIS data over to design and back again in a smooth manner has been a problem we've been asked by a lot of our customers to work on. So one of the things we've been doing is, particularly on the topo-based data model, is modifying the data model to include pole heads. And what this gives you now is when you move from design over to GIS and GIS back to design, it creates the connectivity between the wires and the poles. And by creating that connectivity, it gets two advantages. One is you now have the pole head, so that when you go into design, you know what your takeoff point, the actual pole heads, the height of where they're attached onto the pole. And the other advantage is now in my getting that data back into GIS, I can take a circuit and say, search down the circuit and tell me every pole that's on there. And assuming you got your maintenance history integrated in with the GIS, you can look at things more holistically to go down a circuit and say how many poles on this need to be upgraded and get kind of a better view of everything that's out there. So it's a pretty simple data model change. Typically, when you do this, you either have to go through and set a default in the GIS, or this is what I assume all my pole heads are, and then update the data as you go along, or you can just create the data model and then populate it as you start going forward with the GIS. So one of the other major upgrades we've been doing is interfaces, is in the analysis interfaces. And by the analysis packages, what I'm referring to is the DistriView or Milsoft packages that are out there. And we developed and have deployed two and have tested the other two, just there's no customer yet. 4 ways to get the data from topo-based, from the GIS over into the analysis packages. So if you have a topo base, we have using Map3D FEO connectivity with our plugin. We'll go down the GIS data model and create the SCD file for Milsoft, or it'll write it directly into the DistriView. DistriView being an analysis package that's out there. And if you're an Esri-based system, we just have the plugin that you can use the actual Esri topology. You don't require the FEO, and you can just pull the data out. The major changes we've done with our interfaces, the analysis package, or the enhancement over typically what's out there, is most typically it's just a view between the Esri or the GIS over the analysis package. And with the view, it's very hard to take care of missing data, bad data. So with the analysis package that has come up, we're using now, is it actually starts at the breaker and traces down using the topology in the GIS to recreate that circuit. And then if there's missing data like the kilowatts aren't there, or you have one of the problems that typically we've seen is capacitor banks but not the number of capacitors listed in the bank, it'll put a default value in there so that you can create that circuit. The other advantage that we have, particularly on the Milsoft interfaces, is that by using the STD format, which is the preferred Milsoft interface, it's a much richer interface. If you use the multi-speak, by definition, multi-speak is a 80% solution, so you're cutting off the data at the end of the bell curve whenever you do an 80% solution. So you get a much richer interface that's out there. You can do it by circuit, or you can do it by the entire network. So you can pick one circuit and say update the circuit in Milsoft, or you can pick the entire network and update in Milsoft. So this is just kind of a high-level example architecture, kind of what we've been deploying, particularly in the municipality area. You have your finance, your work management system. You got AUD using the token-based electric model, and the reason the utilities, the municipalities, will want to use the AutoCAD data model is because it is actually more in line from the electrical standpoint with what the design wants. And then, so you pull in your work orders, your bill of material, do your design in AUD using the map 3D, export that data out to your network analysis, your OMS packages, and then what we're also working on right now is interfacing SpiderCalc in with AUD. So I'll be going through those slides in just a sec. And then substation design, we're going to bring it in, interfacing with the GIS and the work management system. So just want to go through a concept that we're working with a couple of other vendors, and it jointly is called no pole standalone 360-degree analysis. And what we're trying to do is there's a lot of very, very good tools on the market for analysis, and no one tool does everything. You have to have a suite of tools. What you want to try and avoid is have to do the manual movement of data from one application to the other. So the first part that's out there, of course, is physical analysis. And on the physical analysis, you have the nonlinear analysis, which is the vertical on the pole, how much stress is on the pole from the vertical. And then that pole, of course, is connected to another pole, so you have the linear analysis, your sag calculations, ground clearance, your pulling tension, and those type applications. And the other part that you have to know is your electrical analysis, which is this overall network, not just the design that you're working on, but what's the impact of that design on the overall network. You got, during your design, you got your flicker, your voltage. For your network, you got to have reliability analysis, short fault circulation, arc flashing, and the entire, how is this impacting the entire network. So what we've seen is kind of working with a bunch of different vendors. We don't sell any of the software. We just kind of work with everyone. And so we've been talking, and we have actually another meeting coming up at Tech Advantage next week with SpiderCalc, Milsoft, Autodesk, to try and tie everything in together. And we've been doing some prototyping, and we're getting ready to expand this out. And hopefully we should be able to have this in just a couple of weeks for those that are interested. So if you look at the calculations, AUD provides your engineering calculations, your guiding, your clearance, your transformer, linear zone clearance, Polehead selection, and the basic engineering of the design. SpiderCalc does complete stress analysis on the pole. It does wind analysis, soil, takes everything into account, and the bucking, not just on the snapping, but the entire pole, load stress analysis, zone clearances, and pole route analysis. Of course, Milsoft and/or Distribute both supply the network analysis to get an evaluation of the overall system, power voltage drop, fault connections, IEEE type rating standards. So the typical workflow that you'd be able to implement once we get these integrated together is you would start at Milsoft, do a network analysis, find a potential problem in the overall network that needs to get done. You would use your AUD integrated in with your finance and your work management system to create the design and then export that back out to the warehouse so they can pull the crew. But during the AUD, you would be able to do all your linear analysis and some physical analysis. Once you have a proposed design, if you can ship that data out for SpiderCalc, SpiderCalc can do a much stronger, detailed vertical pole analysis on that pole and change some of your zone clearances, upsize the pole, ship that back to AUD, which would then upsize that pole. SpiderCalc looks at individual poles versus the group of the poles. So once you ship to SpiderCalc and they can upsize the poles and do a more detailed, ship that back to AUD, AUD would accept that, modify its material list. Once it modified that, it would reanalyze the entire, from the linear, what's the impact of changing that pole against the entire design, and then continue to ship that off and follow through the standard workflow of getting it out to the crews, getting the as-built back in the system.